Okay, so we're going to look at function notation. Like you had stated, the very first one here is just replacing the x's in this equation with the number 2. So that one's pretty straightforward. We're going to jump past that. We're going to focus on, I think we'll do D and G. E is just, it's very similar to what G will be. G's got a negative, so it might be a little trickier, but we'll start with D. D is actually very similar to the first one, but instead of replacing this function here, so we have f at x, I'm going to write it on the right-hand side here. F at x is equal to negative 4x squared minus 5x plus 2. Instead of replacing the x in the equation, so that's this, with the number 2 that we had stated here, we're going to be replacing it with negative 3x, sorry. So I'll write the rest of this in black, and then anything that we change, we'll change to red. So we have negative 4, and then instead of x, we're going to write negative 3x, because we've replaced x with negative 3x, minus 5. We'll replace x again with negative 3x, and then plus 2. Now what we're going to do is simplify. So it's not going to be just a single numeric answer where we have just one constant. We're going to have variables in our answer here. So the first thing we'll do is we'll deal with the exponent in the first term. Negative 3x squared. X times x is x squared, and negative 3 times negative 3 is 9. So we'll actually have 9x squared. I'm going to keep it still in brackets because we still have to multiply by negative 4.
Why is it 3x?
Why is it 3x in the function or right here?
The function.
So the question is just saying that we're going to replace the value of x.
Oh, yeah. Oops. Okay,
Yeah.
I see that.
That's okay? Yeah?
Yeah.
Okay.
I got it.
Yeah, no worries. So once we've done that, we're going to move on to the second major term here. We have negative 5 times negative 3x. We're going to still leave that term we're going to multiply by. Sorry, no, that's a lie. I thought there was a squared on it. We're actually going to replace the whole term here. And because it's negative 5 times negative 3x, we're going to end up with positive 15x plus 2. Okay? I'm still going to work on that first term. Negative 4 times 9 should give us negative 36x squared plus 15x plus 2. And that would be it for the function find the following. This is finding the following. None of these are like terms. There's no variable here. The variable here is technically to the power of 1, and this variable is to the power of 2, so we can't collect anything else. This is a simplified version. They may ask us to do other things with it, but this would be an acceptable answer of expanding and simplifying. The one that's going to be a little trickier is we'll rewrite the f at x function again. I'm gonna write over e here because we're going to need this whole space. Remember that f at x from the original equation here is equal to negative 4x squared minus 5x plus 2. In this function, we write f, instead of x, is x minus 1. And all that means is we're going to replace x with x minus 1 throughout the equation. X minus 1. Bless you. Okay. Same concepts. What will be trickier in this part is distributive property, binomial distribution, which sometimes they'll call rainbow method or FOIL. I'll do that kind of up in the top left corner to start, but I'll show you what I mean by that. Right here, we have x minus 1 squared is actually the equivalent of x minus 1 times x minus 1. So what I'm going to do is I'm going to equate that up here, and then I'm going to replace it down here, just because I don't have too much room, and we do want to address some of the questions below. So what I mean by FOIL is that's where you do the first terms, then the two outside terms. So first terms, outside terms, and then inside terms. So you do both of those, and then last terms, they call it. Okay, and that's essentially multiplying everything twice. You'll end up in a scenario with x squared minus x plus 1. We'll collect like terms. Just the two terms in the middle are similar. So we have x squared minus 2, because technically each of those has the coefficient of 1 in front of it. So it's negative 1 subtract 1, which gives you negative 2x plus 1. And then that would be the simplified form of x minus 1 squared. So what we do now, I'm going to still keep it in brackets. We have x squared minus 2x plus 1. So all we did there is we expanded this into this form, okay? The squared is gone because that was part of the expansion. In the second term, we're going to take this negative 5 and we're going to apply it to both of the terms within the bracket. This is known as distributive property. So negative 5 times x is negative 5x. Negative 5 times 1 is positive 5. And then we still have plus 2. We have to apply distributive property again. So that's this negative 4 times each of these terms. Okay. I'm going to kind of move the equation over here just for room's sake so we can deal with some of the stuff at the bottom. Negative 4 times x squared will give us negative 4x squared. Negative 4 times negative 2 will give us positive 8x. Negative 4 times positive 1 will give us negative 4. Oh, good thing I know what 1 times stuff is. We'll still have this term here, negative 5x, and 5 plus 2 will give us 7. Okay? We've done that. Same thing as before. We're going to collect some like terms. The 8x and the 5x are like terms, and the negative 4 and the 7, those are like terms. They're both constants. I don't have a like term for negative 4x squared, so that's going to stay the same. So we'll leave that as negative 4x squared. Positive 8x minus 5x, so just think of it as 8 minus 5 becomes positive 3x. And then negative 4 plus 7, so think of it as like negative 4 plus 7, we end up with positive 3. And now everything is its own. There's no more like terms. We have a constant. We have a variable to the power of 1. And then we also have a variable to the power of 2. So that would be the simplified version of this. So a little bit more work than when we plug in the number 2. Okay?
Wait, why when x plus 1 squared is x squared minus 2x plus 1?
This part here? Yeah, okay, I can show you that. I'll write it out in a little more detail. I'll write it at the bottom and then we'll end it from there. So let's redo this. This is considered distributive property. They'll call it FOIL sometimes, so I'll go into a lot of detail about this. So are you okay with the idea that x minus 1 squared is the equivalent of x minus 1 times x minus 1? Does that idea make sense? Is that okay? So once we've done that, just like the distributive property that we had up here, where I took this outside term and I had to multiply it by both of these, I have to do that for think of the first set of brackets. I have to multiply this term by both of these, and then I have to multiply this term by both of these. Okay? So they sometimes call this FOIL, and I'll show you the process on the side because there's a little room over here. What's going to look like, we'll rewrite it, x minus 1 and x minus 1. Okay, FOIL, I'm going to write it out here. F is first, outside, inside, and then last terms. And that's just referring to the order of the terms here. So the first terms are the first terms in each set of brackets. So x times x gives us x squared. So check, we've done the first terms. And then the outside terms, think of it as the very first term and the very last term. So that's still the x in the first term, but this time times negative 1. X times negative 1 gives us negative x. So we've now done the outside terms. Next is the inside terms. So think of the terms that are closest together in the middle. That's negative 1 times x. Is the exact same answer as before. Negative 1 times x is still negative x. So we've done the inside terms. And the last term is, think of the last term within each of the brackets. Negative 1 times negative 1, which will give us positive 1. Once we've done that, we're actually on this line here again. I'm going to collect like terms. And what I should have done is that, just to make it clearer, technically this is negative 1x, and technically this is negative 1x. When you're collecting like terms, the variable stays the exact same. You just deal with the coefficient. So think of the idea of negative 1 minus 1. So if you're on a number line and you're sitting at negative 1 and you go back 1, that's the concept of negative 1, you end up at negative 2 when you go on the number line. So that means these two together actually simplify to the value of negative 2x. The other two things don't have like terms. So x squared minus 2x and then plus 1. And this is, though it's super colorful, the exact same thing as we had here, which is what we plugged into the equation down here. I just went through it a lot quicker. They call that binomial distribution, but usually in grade 10, it's commonly known as like FOIL or rainbow method or like a style of distributive property.